Enzyme activity drives biological systems, but how do we capture its invisible reaction? By quantifying substrate depletion or product formation through spectral photometry. We review catalytic efficiency under controlled conditions. These measurements bridges biochemistry to medicine and biotechnology. Let's decode the kinetics. Before we start, let's first get a view of the basic knowledge of this topic. You may ask, what is enzyme? An enzyme is a biological catalyst. A catalyst is a chemical agent that speeds up a reaction without being consumed by the reaction. Therefore, enzyme can speed up chemical reaction and it can be reused for several times. So how does enzyme work? The enzyme binds to a substrate, the reactant that an enzyme acts on, forming an enzyme substrate complex. While bound, the activity of the enzyme converts substrate to product. What is worth mentioning is that the reaction catalyzed by each enzyme is very specific, which means that most kinds of the enzymes are designed for only acting with one kind of substrate. However, same as in organic catalysts, enzyme activity will be affected by general environmental factors such as temperature and pH, and chemicals that specifically influence the enzyme, such as enzyme inhibitors. As we can see in the graph, each different enzyme can have different enzyme activity under the same circumstance, even though they have the same function as they are evolved to fit the environment they stay. After learning this basic knowledge, it can be easier to comprehend our experiment topic, measuring lactase enzymatic activity. Lactase, the enzyme of interest in this experiment, is a glycoside hydrolase that breaks down galactose, a disaccharide in milk, into monosaccharide components, glucose and galactose. This response is crucial for humans to digest lactose, especially during infancy when lactose is the main source of nutrition. However, some people suffer from lactase deficiency, resulting in lactose intolerance, a condition characterized by an inability to properly digest lactose. The objective of these experiments was to determine lactase activity under controlled conditions. But how? We want to use spectrophotometry, which can determine the concentration of a solution from the amount of light it absorbs according to the Lambert-Beer law. To do that, either the substrate or the product of the reaction must absorb light in the UV-Vis spectrum. However, none of lactose, glucose, galactose do. So we are going to use another molecule with beta-glycosidic linkage that mimics the shape of lactose. The hydrolysis reaction can also be catalyzed by lactase. One of the reaction products, also nitrophenol, has the maximum absorbance at 420 nm so that we can measure enzyme activity by measuring the concentration of orthonitrophenol and the reaction time. To begin with, lactase was extracted from commercial lactase tablets by crushing one tablet into a fine powder using a mortar and pestle. The powder was transformed into a 15 ml tube and 10 ml phosphate buffered saline was added to suspend the powder. The mixture was voltaxed for 1 minute to maximize enzyme extraction. The suspension was then centrifuged at 10,000 rpm for 1 minute to sediment solid particles. The supernatant containing the lactase extract was transformed to a clean 1.5 ml tube. The enzymatic activity of lactase was measured at 37 degrees using ONPG as a substrate. A total of 14 microcentrifuge tubes were prepared, each containing a mixture of PBS buffer, ONPG, and lactase extract. The tubes were incubated in a dry bath at 37 degrees for specific time intervals. After each time interval, the reaction was stopped by adding sodium carbonate. The absorbance of the resulting solution was measured at 420 nm using a spectrophotometer. Control reactions were also performed to account for any non-enzymatic hydrolysis of ONPG or background absorbance. The results shows that lactase does have the ability of speeding up reaction. So how can this experiment connect with the real world? Actually, enzyme is very commonly used in our daily life. For those low lactose intolerant people, lactase can be used to produce low lactose milk, which will not cause bloating and other disease caused by low lactose intolerance. Also, papain is a natural protease extracted from papaya, which can tenderize meat by breaking down collagen and elastin in the meat. Surprisingly, enzyme can also be detected in your washing powder. Several kinds of enzymes that can specifically bind to target stains, such as proteins, starches, fat, etc., can break down stains into smaller molecules that are more soluble in water. The process of enzyme de- decomposition typically occurs under mild conditions, causing minimal damage to fabrics. Additionally, the decomposition products are easily biodegradable and environmentally friendly. Because the universality of the enzymes in our daily life, measuring enzyme activity under different circumstances is very important to use them correctly. While we are approaching the end of this video, before it ends, I want to give a big thank to Professor Lee for his creative and engaging teaching method and devoted teaching. Also, I want to thank my ThinkPairShare group members for their help when doing ThinkPairShare, which is a really enjoying process that provides me with many fresh perspectives on biology knowledge. Thank you so much for watching this video.